Discuss here how Google designed their library, the newer Bluetooth API, which is otherwise known as GMS dot nearby dot connections. In communication in general, there is always an asymmetry. One party should play as the server, and the other party should play as a client. Even in TCP/IP, BSD sockets, network programming, that has always been the case, that the other side is a server and the other side is a client. And along with these asymmetries, the API calls on either side will be a little bit different. And this is what we're going to discuss here. So in the Android newer design of the Bluetooth API, one node does the advertising. We can consider this as being the server. The other node starts the discovery. We can consider this as being the client. Although we have to take note that in TCP/IP scenario, the devices are already connected because both of them have the wires connected to the router. So even though the applications could not see them, but at the hardware level, they are already connected by a wire, right? So it has an IP address, etc. In the Bluetooth scenario, there is no such connection because it is open air and it's like open space. There is no cable. So somehow the client has a need to do a discovery. It starts to scan for RF packets within the Bluetooth RF range. And when it finds a Bluetooth RF packet, then it starts to act on that packet. Okay, I say to act because we are not yet sure if indeed that packet is a Bluetooth device. It could be a microwave, for example, because it is within the range of the Bluetooth frequency. So crucial to this library design, because we are focusing on the design of this library, and I'm more interested in how the library is designed. There is an asymmetry here, and we have to notice this asymmetry: the discoverer and the advertising. The asymmetry is this one. The discoverer passes a list of methods in the discovery. The advertising is passing a list of methods here. That is a very crucial asymmetry between these two calls. You see, the code name, this is a useless thing. It's not of much use. You could use any words there. You could put your name there. And now we can already see that they are asymmetric in this parameter. Both the discoverer and the advertiser is passing in a connection ID, and they are also passing in a strategy, and they are the same on both sides. So we can begin to see now that they only differ on this part. Now the M discovery are just two methods, wherein if the discoverer finds another device, then one of those methods is invoked, the onFound device method. And the advertiser has a lifecycle method, and we will see these methods later on. But before I go there is also a third set of methods, which is the method invoked when a data is arriving to a particular Bluetooth device. Like if a data is intended for that device, the operating system obviously already have received the data. Now it's time to notify the application. and that API is the payload API. This one. On payload receive. Now both the discoverer and the advertiser have a need to get hold of this payload interface or callback, because this is the mechanism by which an incoming payload is delivered. Let's go back again to the receive. If we go to the advertiser and we trace the life cycle, which is this one, and we can see that, and right now we know that the life cycle is being the advertiser has a hold of this life cycle. When the discoverer is able to find it, then the discoverer will attempt to connect, and the advertiser will be aware of it, that somebody is attempting to connect into it, and now it starts to accept the connection. Now this is where now I will a little bit describe, because the accept the accept semantics is in C network sockets programming is only on the server side. See, in BSD network sockets programming, the client will do a connect and the server will do an accept. But here the advertiser is doing accept, which makes sense, okay, because the advertiser is the server. But as I will show you later, if we go back again to the discoverer, it passes in a discovery functions, and if we go to this discovery functions, when a device is found, then the discoverer will request a connection to whatever it found, and then at this very moment it passed in the life cycle. So now we can begin to see that the discoverer also now has the life cycle methods. Now if we go back to the life cycle methods here, the on connection initiated is actually invoked on both sides. So this is a symmetric invocation. The operating system calls the on connection initiated for the advertiser, and it also calls the on connection initiated for the discoverer. So this accept connection, okay, is now being invoked on both sides. So as you can see, if you have done C network sockets programming, you will begin to notice this one, the semantics of this one. Although it is just an API name or a function name, but for those who have done network programming in C, you will begin to notice this. And it's important to emphasize that in this library, they design it in a way that this call is common to both sides. So it does not mean that because the accept connection is only for the server, it's also for the client. And of course, it makes sense because this is just a library, and the better that we can abstract the difference between the client and the server, the better the API is. I will agree to that. But just to describe it, this library is well designed because of this. So the higher the abstraction is, the lesser is the distinction between client and a server. Of course, I have to, if you notice, the M discovery callback, the on endpoint found only occurred for the discoverer, for the client. And in fact, in addition to that, the request connection the request connection only happened for the discoverer. The advertiser could never request for a connection. Okay, and it is this discovery interim structure wherein it can plug in the lifecycle methods, and from there, both sides will have symmetrical layers, symmetrical form. Um, when both sides have the life cycle, and as you can see, they're being plugged in with a payload. See, the advertiser will have a payload methods. The discoverer will also have a payload methods, and from there, the on payload received will be accessible on both sides. So when the data arrives on each node, the functions in this on payload will be invoked for whichever side is the data is arriving. So yeah, I am reminded before that before there was an operating system, you when the way that we program is that we call we call to whatever needs to be called, right? Like open port, something like that. But when we do Windows programming, then the flow is inverted. We are being called now. Like I remember when I did MFC Visual Studio, like on WM Paint, on Draw, on Erase, or on Destroy. So so it's like this. Like maybe some of you guys have started programming, started doing it like this. But before, when there was no that much layer or operating system, we are the one who call. But now we are the one being called, like this one. The a payload is received. Okay, so I think that's a little bit funny that it has this patterns like this just keep on popping up, and and that's and this is how you can understand how they designed the Bluetooth, the new Bluetooth Android API. Thank you.